Hello everyone, I am Prabhu Bevin Marad, Assistant Professor, Department of CSC, BADCET, Vijaypur. In this video, I am going to discuss about the concepts of queuing models. So, today's topic of discussion is characteristics of queuing system and Kendall's queuing notation. So, let us first understand what are the characteristics of queuing system. So, the learning objective is the typical measures of system performance, that is queuing system performance, that is server utilization, length of the waiting lines and delay of the customer. For relatively simple systems, compute mathematically, and for a realistic models of the complex system, simulation is usually required. So, we would be dealing with the following concepts, that is general characteristics of the queuing system and meaning and relationship of important performance measures, and these parameters we are going to discuss in next lecture video. So, introduction to queuing system. A queuing theory is a study of the waiting lines. So, let us take an example of hospital. So, there the patients will be waiting in a queue for paying the amount or purchasing the medicines, and in a production line the cases and case packers are the servers and cases are the customers, and in a computer the jobs are the customers and CPU and disk and CD are the servers. So, all these systems will follow the concept of the queuing theory. So, queues form in a business process as well. It is one of the oldest and most widely used quantitative analysis technique. The queuing system, in a queuing system, waiting lines are an everyday occurrence for most of the people. So, most of the people will experience the concept of queuing theory and such as waiting lines and getting a service from the particular servers, and queuing models provide the analyst with a powerful tool for designing and evaluating the performance of the queuing system. So, the key elements of the queuing systems are customers and servers. So, these two are the important elements of the queuing system. So, because of customer and the servers, a queuing system has been formed. So, the customer refers to anything that arrive at a facility and requires some service. Say for example, the people, the machines, the trucks and emails, and servers refers to any resource that provides the requested service, such as the nurses in a hospital will provide a service for the patients, and the receptionist for any reception desk will provide a service for the people, and cashier is a server who provide a service for the bank account holders. So, the following table shows the example of different systems and the customers who are involved in a system and the server who give a service. Yes, the next concept is the queuing system. So, let us give a proper definition, formal definition for the queuing system. A queuing system consists of discrete objects, we shall call it as items, that arrive at some rate to the system. Within the system, the items may form one or more queues and eventually receive the service, and finally they will exit from the system. So, the following diagram shows a schematic diagram of the queuing system. So, every queuing system will be having a calling population. So, the calling population will be having the potential customers. So, from the calling population, the customer will enter into the queue before getting a service from the servers. So, a queue is nothing but the waiting lines of the customers who are about to get a service from the server. Once a service is received, so they may exit from the system or they can again go back and join to the calling population. So, the characteristics of queuing system. So, in order to analyze such a queuing system, the following characteristics we should understand. So, the following are the characteristics of the queuing system we should specify. Okay. So, every queuing system will be having the following notions. So, they are the calling population, the system capacity, the arrival process, queue behavior and queue discipline, and service times and service mechanisms. So, let us first understand what is this calling population. So, the calling population of a customers is referred as a, so the population of the potential customers who are waiting outside a system for getting service, they are called as the calling population. The calling population may be assumed to be a finite or infinite. So, in case of the finite, let us take an example of a bank where the 5 ATM machines are present. So, in case of infinite calling population, the arrival rate of the customer is not affected by the number of the customers being served and waiting. So, here infinite customers will be standing outside a system for getting a service. So, the next notion is system capacity. So, there may be a limited number of customers who can wait in a queue. So, if an arrival customer finds the queue is full, they return to the calling population. So, the system capacity is nothing but the number of the customers who can wait in a line, nothing but queue for getting a service. So, limited capacity may be there and unlimited system capacity may be present in a queuing system. A limit on the number of the customers that may be waiting in a line or a system. Say for example, an automatic car wash only has 10 rooms for 10 cars. Okay. So, which has to wait in a line to enter the mechanism. So, this is called as limited system capacity. In case of unlimited system capacity, let us take an example of concrete ticket sale. So, where there is no restriction on the number of the people allowed to wait to purchase the tickets. The third notion in a queuing system is the arrival process. So, the arrival process is nothing but the fashion how the customers are going to arrive to the system for getting the service. So, are usually characterized in terms of the inter-arrival times of a successive customer. So, inter-arrival time, the time between the arrival of the successive customers. So, arrival may be scheduled times or at random times. So, when the arrival times are characterized as a random times and they are defined by using probability distributions. So, in addition, the customer may arrive one at a time or in terms of the batches. So, the batches may be of constant size or random size. So, a second important class of the arrival is scheduled arrival. So, the patients to physician office or scheduled airline flight arrive to the airport. So, the following figure shows how the customers are going to arrive to the system. So, the arrival of the customer may be random arrival times, fixed arrival times and fixed with variation arrival times, fixed size batches of the arrival and random size batches of the arrival. So, arrival process is nothing but how the customer is going to arrive to the queuing system. So, the random arrival can be characterized by Poisson distribution. So, the Poisson distribution is nothing but average arrival rate is also known, and average arrival rate is constant for some number of times period, and the number of the arrivals in each period is independent in case of the Poisson distribution. So, the Poisson distribution is given by the probability of x equal to the probability of nothing but the probability of exact x arrivals occurring during one time period. It is given by e raised to minus lambda, lambda raised to x divided by x factorial. Okay. So, here the lambda is nothing but the average arrival, the average customer arrival rate per time unit. So, the fourth notion is queuing behavior or the behavior of the arrival. So, nothing but the behavior of the customer in a queue. So, the queuing behavior is defined as the action of the customer while in a queue waiting for the service to begin. So, the following are the three different behaviors of the customers who are standing in a queue. So, the behavior of the customer in a queue will define the behavior of the queue. So, a customer may leave when they see that the line is too long, and the customers may leave after being in a line when it moves too slowly, and some customers in a queue may move from one line to the another line to a shorter line, right. So, this figure shows the different behavior of the customers who are waiting in a queue. And next is queuing discipline. So, it refers to the logical ordering of the customer in a queue and determines which customer will be chosen for the service when the service becomes when the server becomes free. So, the following are the different types of queuing disciplines. So, first in first out, last in first out, and service in random order. A server may start a service of the customer in random order, and a server may start the service of the customer shortest processing time first. So, depends upon SPT, and depends upon priority, a server may start a service for the customer. And say for example, in some job shop, the queuing disciplines are sometimes based upon the due dates. So, another one is on expected processing time for a given type of the job. So, depends upon the type of the job and when it is going to complete. So, depends upon that a service will be chosen for the customer. So, this diagram shows the different queuing discipline, and fifth one is service time and service mechanism. A service time is nothing but what here the how the service is given for the customer. So, that the service time of the successive arrivals are denoted by S1, S2, S3. So, this is service time of customer 1, service time of customer 2, service time of customer 3, and so on. So, they may be constant or it is a random duration. So, customer may get constant service time or it may be random. So, the exponential, Weibull, gamma and log normal and truncated normal distributions, all these are distributions which are used for modeling a service time in a different situations. So, some services are identically distributed for all the customers or of a given type or class or a priority. So, some system service times depends upon the type of the the time of the day or upon the length of the waiting line, right. So, the service mechanism is nothing but how a service is provided for the customer. A service may be provided by using a single server or parallel server. In parallel, a service is given for the customers who are waiting in a queue. So, that is called as service mechanism. So, these are the few examples of queuing models. So, here 3 servers are there, 3 server. So, these 2 servers are working in parallel. So, this is a third server, right. So, the customer will enter into the system. They will be waiting in a Q1 and Q2, and Q1 customer will be getting a service from the service counter 1. Q2 customers will be getting a service from the service center 2, and after that the customers who come out from these two service centers. So, they are going to join again and they will be waiting in a queue 3, and service center 3 is going to give a final service for the customers. So, once after getting a service from the system, they are going to depart from the system, and this is another example. So, a customer will be entering into the system and they may get a service from any one of these servers. So, these are the parallel servers. So, this is an example of a queuing system where the parallel servers are working, and this is another example. So, here the customer will enter into the queue. So, queue 1 customers are served by only one server, and here 3 servers are for queue 2 customers, and after that they will join to the queue 3, and finally they will get a service from the service center 3 and they depart from the system. So, all these diagrams shows the different queuing models. So, the next concept is Kendall's queuing notation. So, the Kendall's queuing notation is one of the shorthand notation for identifying the diverse queuing models, the different types of the queuing models. So, the purpose of using Kendall's notation is to recognize the diversity of the queuing system. The Kendall has proposed a shorthand notation to characterize a range of the queuing models. So, the Kendall's notation is given by, that is A bar B bar C N bar K bar SD. So, here A represents the inter arrival time of the customer, that is inter arrival time distribution. Okay. So, the inter arrival time may be any one of these 3. The inter arrival time may be deterministic, or it may be a general, or it may be a M. So, M means what here? Exponential distribution, right. And B is nothing but service distribution time. So, the service distribution time may be any one of these 3 distributions, that is deterministic, general or exponential. And C represents the number of parallel servers, N represents the system capacity, and K represents the calling population, and SD represents the service discipline. So, by default the service discipline is first in first out, and calling population is infinite, and system capacity is also infinite, right. So, this is a queuing system. So, where K represents what here? Calling population, A represents arrival process of the customer, and B and C represents the service time distribution and number of the parallel servers, and ST represents the service discipline, and N represents the system capacity, right. So, let us see few examples. So, M bar, D bar, 5 bar, 40 bar, 200 bar, FC, FS. So, here M is nothing but what here? The A, and the D is nothing but the B, and C is nothing but the 5, and 40 is nothing but K, and N is nothing but 200, and ST is nothing but FC, FS. So, we can say that this is a queuing system where 5 number of parallel servers are present, and service time and arrival times are exponentially distributed, and the system capacity is say 40 and calling population is 200, right. And let us take another example, M bar 1. So, we can elaborate this particular queuing model as a, so this is a queuing single server queuing system where the arrival time and inter arrival time and service times are exponentially distributed with infinite number of the servers and infinite calling population, and the service discipline is FC, FS, that is first in first out. And we will see another example, that is G bar 1 bar 5 bar 5. Though this is also a single server queuing system where the inter arrival time and service times are generally distributed, and system capacity is 5 and calling population is 5, with the service discipline is first in first out. And let us consider another example, m bar 1 bar infinity. So, here a service discipline has been not given. So, by default the service discipline is first in first out. So, we can say that this is a queuing model where single server is there, and the service time distribution and arrival time distribution is exponentially distributed with infinite system capacity and infinite calling population, with the service discipline is first in first out. Thank you. So, please subscribe to my YouTube channel to see more videos on system modeling and simulation.